Hi guys, welcome back. Today we are going to learn about bounds and error intervals. We've got 4 success criteria, and the first one is to find the upper and lower bound for numbers rounded to the nearest tens, hundreds and thousands. So if x is 60 and it's been rounded to the nearest 10, we want to write down the upper and the lower bound for x. So if we have a look at 60, which is on our number line in the middle, and think about what tens are below 60 and what tens are above 60. So the 10 below 60 would be 50, and the 10 above 60 would be 70. Now, if a number's been rounded to the nearest 10, and it's been rounded to 60, that means the smallest it could have been would be 55, and it's got to go up to 65. This is what's known as the upper and the lower bounds. So the lower bound would be 55, and the upper bound would be 65. So the number must be somewhere in between 55 and 65. If it was smaller than 55, then it'd round down to 50. If it was bigger than 65, then it would have been rounded up to 70. So the number that's been rounded must be somewhere in between 55 and 65. Now the trick to finding the upper and lower bounds is to simply half the amount that it was rounded to. So it was rounded to the nearest 10, and half of 10 is 5. To find the upper bound, we add 5 onto 60, and to find the lower bound, we take 5 away from 60. So the lower bound is 55, and the upper bound is 65. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, y equals 4,800 and it's been rounded to the nearest 100. So we want to write down the upper and the lower bound for y. So if we have a look at 4,800 on the number line, so it'll be there. The 100 below 4,800, 4,700, and the next 100 would be 4,900. It needs to be somewhere in between here, in between 4,750 and 4,850. So the lower bound is 4,750 and the upper bound is 4,850. Using method 2, it's rounded to the nearest 100. So if we half 100, that's 50. And to get the upper bound, we add this on to 4,800. And to get the lower bound, we take this away from 4,800. So the lower bound is 4,750 and the upper bound is 4,850. Here's some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answer. And now we've completed success criteria 1. So now we're going to move on to number 2, and this is to find the upper and lower bounds for numbers rounded to the nearest decimal place or significant figure. So x is 600, and it's been rounded to one significant figure. So write down the upper and lower bound for x. So we want to half the amount that it was rounded to. Now, if it's been rounded to one significant figure, then it's rounded to the nearest 100, because the first significant figure in this number is 6, which is in the hundreds column. So we half 100, which is 50. We add this on to get the upper bound, so 600 plus 50, and we take this away to get the lower bound, so 600 minus 50. So the lower bound is 550, and the upper bound is 650. Here's another example. X equals 0.82, and it's been rounded to 2 decimal places. Write down the upper and lower bound for x. So we want to half the amounts that it was rounded to. Well, the second decimal place is the hundredths. So we half 0.01, which is 0.005. We add this on to get the upper bound, and we take this away to get the lower bound. So the lower bound is 0.815, and the upper bound is 0.825. Here's a question for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. So in this question, x equals 8,250, and it's been rounded to 3 significant figures. Write down the upper and the lower bound for x. So we start with half the amount it was rounded to. So we're looking at the third significant figure. The first significant figure is 8, the second significant figure is 2, and the third significant figure is 5, and that is in the tens column. So we half 10, which is 5. We add this on to get the upper bound, and we take this away to get the lower bound. So the lower bound is 8,245, and the upper bound is 8,255. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers, and there's your amber answers. And now we've completed success criteria 2. So now we're going to move on to number 3, and this is to write error intervals. So an error interval is the range of values that a number could have taken before being rounded. So x equals 24, and it's been rounded to 2 significant figures. So we want to write down an error interval for x. So if 24 is on our number line, and it's been rounded to 2 significant figures. So the number before 24 is 23, and the number after 24 is 25. So x must have been in between here to have been rounded to 24. The smallest that x could have been was 23.5, and the biggest it could have been was 24.5. Now, this isn't actually true because x couldn't have been 24.5, because if it was, it would have been rounded up to 25. So it needed to have been any number between 23.5, including 23.5, but less than 24.5. So we write this in an error interval, like so. So x needs to be greater than or equal to 23.5, or less than but not equal to 24.5. So we write the error interval like this. So we use this symbol as, remember, x couldn't have been 24.5, but it could have been any number less than 24.5. Here's another example. So y equals 0.05, and it's been rounded to one significant figure. Write down the error interval for y. So there's 0.05. One significant figure below would be 0.04, and above would be 0.06. Now y must have been any number in between here, in between 0.045, but including 0.045, but it needed to have been less than 0.055. So the error interval is 0.045, it's less than or equal to y, which is less than 0.055. This is very similar to finding the upper and lower bound, as the largest number is the upper bound and the smallest number is the lower bound. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. When we truncate a number, we always round it down. So if we want to truncate 56.789 to 2 decimal places, we simply take off any number after the second decimal place, no matter what that number is. So we don't round it, we simply remove it. So our answer would be 56.78. If we want to truncate 186 to the nearest 10, well, the tens is the eights, so we put a line behind the 8. Now remember, we don't round the number, we simply get rid of any number behind the tens. So we get rid of the 6, but we need to make sure here we replace it with a 0. So it becomes 180. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So to the nearest 100, it would be 700. To the nearest 10, it would be 760. To the nearest whole number, it would be 763. To one decimal place, it would be 763.9. And to two decimal places, 763.98. X equals 2.6, and it's been truncated to one decimal place. So write down an error interval for X. So the error interval, if it's been truncated, well, the smallest it could have been would be 2.6, but it could be any number greater than 2.6, including 2.6, but less than 2.7. So the lower bound is 2.6, and the upper bound is 2.7. Here's another example. Z equals 15, and it's been truncated to the nearest whole number. So we want to write an error interval for Z. So the smallest it could have been would be 15, and the biggest it could have been would be 16. So 15 is less than or equal to Z, which is less than 16, because it couldn't have been 16. Here are some questions for you to have a go at. Pause the video, and when you're ready to mark your work, press play. Here are your answers. So there's your green answers. There's your amber answers. And there's your red answers. And now we've completed success criteria 3. So now we're going to move on to number 4, and this is to find bounds for number operations. So what is the upper and lower bound for the perimeter of this shape? So the width is 2.16 centimeters, correct to 3 significant figures. And the length is 5.4 centimeters, correct to 1 decimal place. So if we find the upper and the lower bound for the 2.16 and the upper and lower bound for the 5.4, now the perimeter is all the sides added together. So the upper bound for the perimeter would be all the upper bounds for each side length added together, which would be 15.23 centimeters. And the lower bound for the perimeter would be all the lower bound side lengths added together. So that's 15.01 centimeters. James has some ribbon that is 300 centimeters long, correct to the nearest 100 centimeters. He wants to cut it into pieces 10 centimeters long, correct to the nearest centimeter. So write an error interval for how many pieces he could cut the ribbon into. So for the 300 centimeters, it has an upper bound of 350 and a lower bound of 250. For the 10 centimeters, it has an upper bound of 10.5 and a lower bound of 9.5. So if we do the upper bound divided by the lower bound, that would be 36 pieces. The upper bound divided by the upper bound would be 33 pieces. The lower bound divided by the lower bound would be 26 pieces. And the lower bound divided by the upper bound would be 23 pieces. So the error interval for our upper and lower bounds of how many pieces he could cut the ribbon into, well, the smallest amount would be 23 pieces, and the upper bound would be 36 pieces. So the error interval would be 23 is less than x, which is less than or equal to 36. So if we're adding with bounds, to get the lower bound, we add the two lower bounds together. To get the upper bounds, we add all the upper bounds together. However, if we're subtracting, to get the lower bound, we do the lower bound take away the upper bound. To get the upper bound, if we're subtracting, we do the upper bound take away the lower bound. If we're multiplying, to get the lower bound, we multiply the two lower bounds together. To get the upper bound, we multiply the two upper bounds together. If we're dividing and we want the lower bound, we do the lower bound divided by the upper bound. And if we want the upper bound, we do the upper bound divided by the lower bound. So given that a equals 50 to the nearest 10 and b equals 300 to the nearest 100, calculates the upper and lower bounds of these algebraic expressions. So we've got a plus b, b minus a times b, and b divided by a. So we start by working out the upper and lower bounds for 50 and for 300. Find the upper and lower bounds for a plus b. We do the upper bound plus the upper bound is 405. And we do the lower bound by adding the two lower bounds together. B minus a, find the upper bound, do the upper bound, take away the lower bound, which is 305. And to get the lower bounds, do the lower bound, take away the upper bound, which is 195. For a times b, to get the upper bound, we multiply the two upper bounds together. And to get the lower bound, we multiply the two lower bounds together. However, when we divide, b divided by a, get the upper bound, do the upper bound divided by the lower bound. And to get the lower bound, do the lower bound divided by the upper bound. Here are two questions for you to have a go at. Pause the video, and when you're ready to see what you should have done, press play. Here are your answers. So we want to work out the upper bound for the difference between the boys' heights. So for Charlie, his upper bound and his lower bound. And for Alex, his upper bound and his lower bound. So we want the difference between the boys' heights, which means we're going to do a subtraction. And if we want the upper bound, we need to do the upper bound for Charlie, take away the lower bound for Alex. So the upper bound in the difference between the boys' heights is 27.5 centimeters. For the red question, we're asked what is the upper and lower bound for the number of boxes I could stack in the corner in the container. So we want the upper and lower bound for 150 and the upper and lower bound for 25. So for the upper bound, we do 155 divided by 24.5. So that would be 6 boxes. And for the lower bound, we do 145 divided by 25.5. Would be 5 boxes. We found the upper and lower bound for the number of boxes I could stack in the container. And now we've completed success criteria 4. So now that we've completed the last objective, it's time to end the video. Hope you enjoyed it, and I hope you found it useful. Make sure to like and subscribe, and be sure to check out the other videos on the rest of the channel. I'll see you next time. See ya.